Hi, my name is Lauren and I'm going to be talking about methane clathrates, their use as a fuel source, and their environmental impacts. Methane clathrate, aka methane ice or fire ice, is a solid compound of water and methane. Clathrate describes a family of molecules in which one component is chemically trapped within the crystal structure of another. For methane clathrate, methane gas is trapped inside the crystal structure of water, forming an ice-like structure. Here, oxygen molecules are seen in red, hydrogens are seen in white, and the methane is seen in gray, trapped in the middle. The ratio of methane to water is 1 to 5.75. 1 cubic meter of methane ice can contain 160 cubic meters of methane gas, making them a potent energy source. Methane ice was originally only believed to form in the outer regions of the solar system. However, they have been found naturally on Earth at the bottom of the ocean and buried inside permafrost. For formation to occur, low temperature, high pressure, and methane sources must be present. In the ocean, the methane source is from geological faults found deep in the ocean depths. Most importantly, the ice is subject to combustion and is very unstable and hard to retrieve. Methane ice was first discovered in the 1930s by natural gas miners. The miners experienced ice-like material clogging their pipeline, as seen in the picture here. Scientists studied that material and found it to contain ice containing methane. In order to prevent the formation of the hydrate, miners used methanol and glycol in their natural gas pipelines to prevent clogging from methane ice. Methane hydrates are also commonly found in the natural gas production process, when liquid water is condensed in the presence of methane during separation and condensation processes. Even though methane ice was discovered in the 1930s, the Department of Energy did not conduct research on the possibilities of finding methane ice deposits until 1982. The Department of Energy discovered that hydrate deposits have been found in offshore sediments, allowing for the realization that methane ice may be a valuable fuel source for the future. However, the methane ice is very unstable and is difficult to test due to its need for a high-pressure environment. Therefore, it wasn't until the mid-1990s when Japan and India took over methane hydrate research to find a way to extract the trapped methane economically and environmentally friendly. Japan has estimated that there's approximately 1.1 trillion cubic meters of methane in methane ice deposits located off the coast of the Pacific Ocean. If this amount of natural gas was recovered, Japan would be able to stop liquid natural gas imports for about 11 years. Japan has even found 120,000 cubic meters of gas in methane ice 50 miles off their coast. This is just the beginning of the discovery of natural gas hydrate reserves. Japan has spent a lot of time and money trying to find an efficient method to extract methane hydrate from the seafloor. Due to their dependence on imported fossil fuels, finding a way to extract the natural gas from Japan's own shores will lead to independence from foreign sources. Japan has been studying a means of depressurizing or melting the methane hydrate on the seabed and channel the methane gas to the surface for retrieval. Consequently, in 2017, Japanese researchers successfully extracted gas from the methane ice from the bottom of the South Asian Sea. So, with the promising economic prospects of methane clathrate, are the environmental impacts worth the profit? Methane ice is found in sediments on the seafloor. Drilling deep into the ocean deposits can cause sediments to slide down the continental slope. This shift in the seabed can disrupt marine life, the seabed, and even tsunamis. Additionally, due to the possible escape of methane in the atmosphere during the extraction process, methane ice extraction can cause a major increase in global warming and greenhouse gases in the air. Methane is considered to be 25 times more potent than carbon dioxide in trapping solar radiation. On the other hand, natural gas is cleaner burning compared to coal. Therefore, countries like China and India, who rely on coal for a large amount of their energy production, looking at methane hydrate as a source of energy can help decrease the emissions caused by coal burning and in turn create cleaner air. Due to the possible benefits of coal burning countries, the extraction of methane ice must be weighed with the risks of increasing greenhouse gases, disrupting marine life, and the seabed. As you can see in this photo, there are methane ice deposits everywhere in the world. Methane hydrates may represent one of the world's largest fossil fuel sources that are untapped. The future of methane hydrates may be extraction, or they may be left untapped due to environmental risks. Japan is continuing their efforts to begin commercial projects exploring methane hydrate between 2023 and 2027. However, due to methane hydrate having similar environmental impacts to fossil fuels, countries like Japan, China, India, and the United States are going to continue to develop renewable fuel sources. Due to renewables development, the window for the usefulness of methane clathrate may be short, but we may be able to see the use of methane ice as a fuel in our lifetimes. And these are my sources.